Hello, welcome to our regular GraalVM webinar series. My name is Sean Smith. I'm a product manager with the GraalVM team, and today we are lucky enough to have Oleg Shleyev from GraalVM team, the DevRel team, talking about microservices and GraalVM. Now, just some background, we're the team from GraalVM is spread out across the world. Oleg's in Europe, I'm in Canada, we have a team in the US, and we have help behind the scenes from some of the team. So it's quite a global event, and fortunately, we have technology that helps us bring us together and to achieve these webinars. So, Oleg, can you introduce yourself?
Hi, hope you're hearing me well. I'm very excited to be here. My name is Oleg Shleyev. I work as a product manager / DevRel on the GraalVM team at Oracle Labs at Oracle, where we build the excellent solution, which is an Oracle GraalVM Enterprise Edition. And this webcast will talk about how it can help with the microservices by making them more efficient. I think this is the third webcast in the series, so I assume that you have some basic knowledge about GraalVM. So we're gonna go quickly through some parts and dive straight into the microservices.
That's perfect. Okay, I will hand it over to you, Oleg, and then at the end we'll get together and we'll take some questions. If you have questions during the webinar, you can type them into the Q&A box, and we will address them at the end. Okay, over to you.
Right. Thank you, Sean. Let's go. First of all, we need to acknowledge that this is a technical presentation, so please do not make any forward-going business decisions based on contents of this. Thank you very much. And also, some components of the GraalVM distribution are provided with an early adopter status, so we should be mindful of that as well. Having said all that, Oracle GraalVM Enterprise Edition makes Java applications faster, smarter, and leaner. In a nutshell, GraalVM is a high-performance virtual machine and a just-in-time compiler that together provide you with a platform to run your Java applications really, really well. The most direct application of using GraalVM is to run your Java applications as on any other JDK. Right? GraalVM it contains a JDK distribution, and you can use it to run all your Java applications normally, as you would do. The thing is, due to the state-of-the-art just-in-time compiler, which is spectacularly excellent, and it includes tons of patented optimizations as well as normal optimizations the compiler have. If we measure its impact on real-world applications, so here on the slide you can see the graph that shows the performance on the Renaissance benchmark suite, which consists of different benchmarks from different libraries that are very popular currently in the modern Java code. We can see that with the GraalVM Enterprise Edition, you can get approximately, on average, 32% faster execution. So that is a peak performance metric, right? When everything is warmed up, when your application has run for some time, it can go faster. And you should absolutely, definitely check that out. But the question is, in the world of microservices, where our services are ephemeral, right? When we scale them back and forth without actually running them for maybe a lot of time, maybe they're just spinning up to serve a couple of requests or to serve this spike in traffic, maybe the peak performance is not the most necessary metric to optimize for. So in the microservices context, when you deploy fleets of microservices into the cloud, you have a little bit different setup. The components of your system are separated with a network boundary. And every standalone component has the overhead of running the full Java virtual machine just for this particular service. So that creates a little bit of redundancy in this infrastructure level because it pads every service to consume more resources than necessary. So GraalVM has a solution for this, and it's called GraalVM Native Images, which is a technology that can allow you to compile your Java code to the platform native binary. That will not depend on the JVM, and that will start up really, really fast because it doesn't need to initialize a lot of things, initialize the full JVM cycle, and load your classes, verify classes, start compiling your classes. So it will start up really, really fast, and it will be ready to serve business logic and do productive work out of the box. And it will also consume quite a bit of less memory at runtime, because it doesn't include the facilities for JIT compilation, and that is a perfect solution for the microservices in the cloud, where memory consumption and startup are two essential characteristics. In the previous webcast, Java ahead-of-time compilation with Oracle GraalVM by Christian Wimmer, you've learned about this GraalVM native images technology, how it can compile Java ahead of time, and the technical overview of that. So if you want to learn more about that and you haven't seen that, so you should check it out. I know that there is a link somewhere in the resources section about this. So we're not going to talk about the details, what happens inside when we compile applications ahead of time. We're going to talk about how to run that and how to use it. In a nutshell, you take your Java application or an application written in JVM languages, and you use the native image utility from the Oracle GraalVM Enterprise Edition to compile the application ahead of time. That means you take your application, you take your Java classes, your jar files, and you feed to this native image utility. And it looks at it, and it looks at the whole application, everything that it's ever going to run in this application. And it compiles it to the platform binary. However, GraalVM also can run your application with the JIT compiler normally, running on the Java Hotspot VM. So the differences in the approach are the performance trade-offs, the differences in the performance trade-offs for ahead-of-time compilation versus just-in-time compilation. Just-in-time compilation optimizes for the peak throughput and the best latency, right? And we saw that on the benchmarks on the slide with the benchmark presentation before. The peak performance is really, really good. But ahead-of-time compilation makes a different choice. Startup speed, memory footprint, and smaller packaging, which are essential for the cloud deployment, because in the cloud, you actually pay for the memory consumed. So having said all that, I would like to show a short clip of a web application being compiled as a native image, started, and measured the memory consumption of that. Here it goes.
Let's look at the sample application. This is a web application, a small microservice written using the Micronaut framework. Micronaut is a fairly new but established framework for creating microservices. It uses annotations to configure your application, and we see that it's very similar to other frameworks that from the code point of view. We have a controller here, and it will calculate some prime numbers. So when we'll use the application and run primes from to 2, it will compute the prime sequence from to 2. And it will also be able to count the prime numbers between the two given values. This logic obviously is not the business logic normally you would see in a web application, but it will just simulate some business requirements and return us some data. Now, I have this application on a machine that I have in a cloud environment. You can see my application here, and I can run this application normally using the JVM mode. So I will use my Java, and I can tell you that I'm using Java from the Oracle GraalVM Enterprise Edition based on Java 8 currently, and I have my native image utility installed, and it comes from the same package there, and I can run my application here. Java -jar build libs Micronaut example jar file. We can run it. It runs. It starts fairly quickly, and then we can render this application, and I can use it in my browser. If I go to this URL and then I will count the primes between 2 and 30, I will see the result and I can just print them out. This is all normal and good. What I can do now, I can start the same application which I compiled as a native image. If we look at the Micronaut example file here, it's an executable file and it's a binary file. It's a 60 megabyte large. It doesn't depend on the JVM, and I can just run this fairly swiftly. You can see it starts in 21 milliseconds, and then you can see that in the browser, I can still access it, right? So we can change the numbers here, and it runs and it prints us some prime numbers. Between 2 and 23,000, for example, there were 2,500 prime numbers happening. If we look at the memory usage of the microservice like that, we will use the utility that records the memory, and we will give it a process identifier for the Micronaut application. It will give us that it runs with 70 megabytes of RAM, which is quite spectacular, but maybe not even the most optimized. The thing is, this is a very powerful machine, and without the constraints, your native image application will assume running in the powerful environment that it can get more memory that maybe you want to give it. So you can absolutely configure that, and we will do that momentarily. We will start this application, and we will start it like this. So Micronaut example, and we'll give it we will give it, say, 60 megabytes of RAM, right? We will also use a custom bash script that will start our application, bash it with 3 consecutive requests, sleeping between each request a second, and then we'll plot the data for the RAM and CPU usage from this. Let's run it. We run it. It starts really fast, 1 request, 2 requests, 3 requests, and now we need to look at this file. To do so, we're going to start very quickly a Python server, and in the same browser, we'll just go to the same URL, and then we will find the myplot graph here. What we can see is that the RAM usage is 50 megabytes at most, and we can see that CPU only spikes when we actually perform the request. This is a striking difference compared to the normal execution of the Java process. This is what GraalVM native image can give you for your Java-based microservices.
Right. And what's really important is that not only Micronaut application can be compiled as native images. Oracle GraalVM Enterprise Edition has a reasonably established and growing support in the ecosystem. Right? There are web application frameworks like Halidon, which Oracle helps develop as an open source application framework. Micronaut, there is a Quarkus framework. Spring Boot support currently is in the works. There are some issues with the configuration for the Spring Boot applications to make them work as GraalVM native images, and we are working on that, both the Spring team and the GraalVM team. One other type of the application that is benefiting from the quick startup and low memory overhead, because they run typically a very short period of time, are command line applications. And for command line applications, there is a very cool library called Pico CLI, which has support for GraalVM native images, and you can use that if you need to create a command line application for something, and you want to develop that in Java, but you also want it to exhibit the performance characteristics of native applications. And And the great thing about GraalVM native image support is that the results, right, the performance characteristics are almost universal through the whole ecosystem, right? You take a framework that supports native images and you compile your application using GraalVM native image technology, and you get the results which you just saw with the Micronaut application demo, right? So for a Helidon application example, the startup is also just a few milliseconds. For Micronaut, the same, and the others, right? And it reduces the startup number from running with a jet to just a few milliseconds. The memory savings are also universal across the ecosystem of the supported frameworks, right? Both Helidon applications will see much reduced memory usage, and the Micronaut applications and so on, and Spring applications when the Spring Boot support will be enabled. The memory reduction benefits mostly come from not including the just-in-time compilation facilities that need to deal with the class files, class metadata, and compiling those at runtime. So it allows you to save quite a large chunk, a slice of runtime memory usage from every microservice, allowing you to run those applications in very small containers and very small, in very small, maybe cloud services, right? Like a Kubernetes pods or something. And here we see an example. So we saw this graph with the memory usage for the ahead of time compiled compilation, the Micronaut example. And just for completeness, I wanted to show the similar graph for the just-in-time compilation, just for you to understand the benefits that you get from using the GraalVM native image technology on a sample microservice. So if we do the same test with the same application, but we do not use the GraalVM native image, then we'll run with the jet, and you can see that on the right here, there is quite a bit of red, which means the CPU usage spikes in the beginning of the application lifecycle when the JVM starts, and it needs to do a lot of initialization. Right? You need to load the class files, you need to locate things, you need to load them in memory. You can see the memory usage spikes immediately to over 100 megabytes, and this is the hello world, like literally a hello world microservice, right? And then when requests come, you need to do additional work for serving them. That's where the compilation can start and so on. And the memory goes much higher. So in this example, it's 5x memory reduction from using the GraalVM native image technology. However, the memory usage is not the only thing that is necessary and that is very interesting here. Another thing is packaging. And I would like to show you a different example, a different demo, this time the Helidon application, which will package in a Docker image that uses the from scratch container that has nothing else except the image itself.
I would like to show you another example of a microservice that is compiled as a GraalVM native image using Oracle GraalVM Enterprise Edition. This time it will be a web application based on Helidon, which is another web framework that supports GraalVM native images. So this application is a Helidon quick start example. So it's very simple hello world. And I don't think the code part is even that necessary to look at. So I will repeat this experiment. So I run my Java from my GraalVM, and this is a different machine, but I also have a native image installed on it. So what I will do, I will run my Helidon application as usual. Java -jar target Helidon quick start se jar. It starts, and it gives us the URL that will print the hello world message to us. So we can cut it and we can just curl it. So we can see the message hello world. Fabulous. Now, instead of compiling this to native image directly, what I want to show you how it can be packaged in a Docker image to make use the best practices for the GraalVM native images. Right? Because the native image is self-contained, right? It doesn't depend on the JVM. We can use pretty minimal Docker images that do not contain the JVM image, and we can just put the application file in. So the native Docker file for this Helidon application will do the following. It will build the application, it will run the maven command to build it, it will package it as a native image, and then it will use a from scratch Docker image, right? The empty Docker image, and it will put the built application file into this from scratch empty Docker image, and it will specify that as an entry point. So what I can do now, I can run this Docker image, and it will run pretty well. It will print the same URL. So let's see whether it works or not. And it does work. So now this application is running within the Docker image. So if I look at the image characteristics, you can see that the size of this Docker image is 31 megabyte. This is very small. This Docker image only contains our application. It doesn't contain anything else. And if we do the stats command, if we do Docker stats, we can see that this application is using 14 megabytes of RAM, this Docker container. And this is quite spectacular. And packaging GraalVM native images produced with Oracle GraalVM Enterprise Edition is definitely a very interesting opportunity. Because the images do not depend on the JVM, you can get much smaller Docker images that consume much less memory.
Right. Another very important benefit of having the Docker images that do not include anything else, right? The from scratch Docker image doesn't have anything else besides your application. It means that there are less code that can be vulnerable to different issues. This is a very good point, but I'm not a security expert, I cannot comment on that with authority, but just something to think about. So just to summarize this thing, the GraalVM Enterprise application, Enterprise Edition throughput, the performance, the essence of what makes GraalVM excellent is summarized in this graph. We benchmarked a small microservice written in a popular modern framework, and this microservice was accepting HTTP requests, hitting the database, fetching data, and then outputting the data back to the client. Right, a small microservice, what they do. And you can see three metrics here: the JDK12, GraalVM in the JIT mode, and GraalVM native image. You can see that at the very right, so on the x-axis, we have the number of requests sent by the benchmark to the service. On the very right, when everything is warmed up, the GraalVM in the JIT mode absolutely crushes everything else on performance, right, on throughput. It is higher than both native images and JDK output. But on the very left, in the very beginning of the application of the service lifecycle, when it just starts up, the JIT approach needs to warm things up. So the throughput there is quite low for the JIT running systems. GraalVM native image gives you a flat performance profile that is reasonably high up, and on the short-living services or microservices, it gives you the absolute speed up and can serve requests per second to the very best.
I'd like to show you another example of a microservice that
something is happening
as a
with my
native image using Oracle GraalVM Enterprise Edition. This time it will be a web application based on Helidon, which is another web framework that supports.
Sorry for that. I think I might have misclicked the button for the slide and we went back. But yes, so coming back to the slide, GraalVM native image excels at services that have the shorter life cycle. At the same time, its throughput is high enough to be competitive with all other solutions. This is a little bit to the closer part of what I wanted to say in this webcast. There are a lot of additional resources. I suggest you start learning about Oracle GraalVM at the oracle.com/GraalVM page, or you connect with the team on Twitter. For example, we go at GraalVM, or if you drop us an email on the address that you see on your screens, we'll be absolutely happy to answer and resolve all the questions.